Hey everyone, thanks for coming today. My name's Christian. I'm from Booking.com. I work on the Graph platform team. So we build, maintain the entire Graph platform for all of Booking.com. And today we're going to talk about schema scoring, or automatically kind of assessing schemas for quality. Since this is an American conference, I always give a quick breakdown of what Booking.com is. We're an accommodations platform, one of the largest in the world. We're a Dutch company, founded in 1996. And since then, we've continued to grow and grow and grow. Between us and our sister companies like Kayak, Priceline, and Agoda, we do over 1 billion booked room nights per year. And that number keeps increasing. Yeah. So last year, I talked about migrating to federation. So we started with kind of building the graph, or building the monograph, which we called Atom. We started adding data, like 100 and some data providers to it. We continued to scale up Atom. We started to really crumble under the weight of too many MRs. We were a small 3-person team. We'd get 10, 15 MRs a day quite often. We spent every day, all day, doing merge requests and just kind of doing it. We started to migrate to federation and started breaking up Atom. And since then, we've scaled 15x our total traffic volume. This creative interpretation of a graph kind of represents that. So the yellow is our outbound calls to the subgraphs. We had a little bug for a while where the skip directive wasn't working correctly. We fixed that. But effectively, we've grown 15x in about 2.5 years. And that number keeps going at about 4.3%, I think was the number one of my colleagues calculated per month. So we're growing rapidly, mostly due to new use cases more than anything. And last year, this is really what I spent a lot of time talking about. We migrated our legacy services, starting with Perl and Java, all to GraphQL, and different techniques we applied to it. At the end, though, there was a question that for the last year has kind of lived rent-free in my head, which is, how is schema quality maintained? We have 150 subgraphs, or just about there now. And when that question was asked at the end, I talked a little bit about, we have linting in place. We have a centralized pipeline for publishing and schema checks. We do trainings. We do some checks on the schemas and things like that to ensure that we have schema quality. One thing I kind of forgot to mention in that talk was with that original monograph, Atom, we actually were pretty strict about enforcing best practices and standards. We weren't a federation then. We were benevolent dictators for the most part. We really enforced these. And those standards really kept for a long time as we added the first 10, 15, 20, 30 subgraphs. Things were working pretty well. But the issue is they weren't holding up. Now, we were the central authority, so things kept pretty well. We were reviewing every new subgraph that onboarded. And like I said, those norms and best practices continued. But over the last year, we've seen those norms and best practices really start to degrade. We see people ignoring linting, following best practices, just doing GraphQL that is the equivalent to REST. So we really wanted to make sure to get this fixed, and what could we do to fix it? So we thought of the idea of, well, how can we assess schemas automatically? Well, first we wanted to run whatever check we did automatically. We don't want people to fill out questionnaires or Q&As or whatever like that. And this was pretty easy for us. We have like I said, a centralized pipeline for schema publishing. We can just pick up each subgraph every time they check and run whatever scans that we want to do this. We already did this with linting, and we were already reporting back to teams a bit within their MRs, but we wanted to do more than that, more than just linting. The next thing we really wanted to do was integrate with what we call service maturity. At Booking, we put a lot of emphasis on building quality services and meeting like a baseline definition. This involves meeting your SLIs, SLOs, how often you're doing your rollouts, make sure your code is up to date, that you rolled out, you're not waiting like 2 months to do a change. What else do we do? We do MRs, security checks, and a bunch of other stuff. And then there's also like 100 question Q&A that everyone has to fill out once a quarter for each of their services that make sure you're following best practices. No one likes doing it, by the way. We always just set one developer to do it and spend the day doing it. We always feel very bad for them. And that's also one of the things that kind of roped into running automatically. I had one colleague who was helping on another team kind of spec this out. And he said, for Christ's sake, if I have to fill out another Q&A, I'm not doing this anymore. So I took that to heart, and when we designed this, But lastly was don't shame, but encourage. So at Booking, we have a no blame policy. So if you create an outage or do something, we don't blame you. We blame the process or something else that went on that happened. And we really wanted to make sure that was kind of the ethos of this idea. So with this brainstorming session, the question comes down to, well, what do you actually monitor and look at? And so we spent a day, not a full day, but a few hours, talking about the stuff that we've seen. Like I said, we already review schemas every time they join the graph. So we kind of thought about what we've seen there. So cyclical dependencies, we've seen schemas effectively have these cyclical types are just made up completely of like really just generic types that just call each other. It's very strange, but it does definitely happen because people are trying to map these old key value REST stuff to different types, and it kind of comes up. Stale fields, we run thousands of experiments at Booking at any given moment. So people are a bit bad about cleaning up, not being good stewards of the graph and cleaning things up. So we want to make sure that we're checking for that. High nullability blast radius, so effectively people using non-null, like deep in a query or deep in their schema, effectively causing issues to propagate up. We saw some very critical queries at one point due to a service outage effectively caused entire pages to not render. So we wanted to make sure that we were catching that. Linting, well, we do all the standard linting stuff. Pascal, are we checking casing, naming conventions, and there's a few custom rules that are very Booking specific. Large object takes, like I said, people were kind of taking REST and just making it GraphQL. So you would have objects with like 100, 120 fields. It was kind of overkill. Like people weren't spending the time to kind of break things down. So we wanted to kind of look at that. Not denoting fields is personally identifiable information. We want to start kind of having audits for that, just so we know where the fields are within the graph. We saw some teams use up to like 6 or 7 composite keys to kind of bridge these very complex types across the graph instead of having proper service boundaries and proper identifiers that were shared. No contact metadata. We just want to see your contact information in the graph. That's all. And then large number of fields in the requires directive. We see a lot of teams really leveraging the orchestration capabilities of the federation to kind of share data across the graph, but also at the same time, we see a lot of teams really starting to expose data to the graph that's really just meant for another subgraph. So we've seen in cases like 200 fields in the requires directive. The developer experience for that is not there. It's just a giant string. So we want to make sure that people are exposing data for the graph for the client and not just other subgraphs, and maybe pushing that orchestration a layer back. All right, so that's a lot of stuff. But we came down with 4 things we wanted to score for the proof of concept of this. So first was the nullability blast radius. Like I said, we drilled down, we find the deepest non-nullable chain, and effectively we see how much of the schema or how much of a query would be destroyed if that field was null. And we give a score for all of these, by the way, from 1 to 100, 1 being the worst, 100 being the best. And we just kind of do a simple calculation for that. So if your schema has like 100 fields and your thing is going to blow up 99 of those fields, you're going to get a 1. Stale fields, we just simply check if the field's been used in the last 30 days. If it hasn't, it gets marked as stale. And we can do a simple percentage calculation off of that. So if 80% of your fields haven't been used in the last 30 days, you're going to get a 20. Linting, we just kind of roped in our already existing linting process into this, except we assigned some points to it. So warnings are 1 point, errors are 2 points, total number of fields and objects, and we just deduct from that with a floor of 0, or actually 1. And that's simply what we do for that. Lastly is cyclical types. So cyclical types, one thing that we do know is that they are part of the graph. There's a lot of great use cases for it, like parent-child relationships. So if you have father, 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 father is an example I saw earlier today. Like if you're doing genealogy. So what we did here was we just did a simple logarithmic calculation. So the more of the graph that is made up, the worse your score is going to get logarithmically. And so that's simply what we did for that one. So from there, how do we actually calculate the final score? Here's this fancy equation. That is technically it. We debated some different ways. One of the colleagues came up with several different ways using credit scoring. But we settled on this equation. This equation is just simply what's called a harmonic mean. Unlike a traditional mean, where you're just kind of averaging things out together by adding them and dividing. A harmonic mean effectively is more impacted by larger outliers. So effectively, if you have a 0 and all hundreds, your score is not going to be very good still. You don't get to have a good score just because most of your scores are good. The other thing here is, which is the W, is we do apply a weight to these scores. So we think linting and stale fields are a bit more important than the other two at this time. Those are the ones that are actionable, easy. No one can really debate that those are bad things. So we apply a higher percentage on that. I believe we do 35% of the scores on those two. And just to give you an idea kind of what that looks like is, here's a little table. So if you have 90, 90, 10, 90, your score is going to drop to 40. With an arithmetic average, it's going to be a 78. And again, 10, 100, 100, 100. Because the ESLint score is so important, it really drops your total score down. Now, with these scores, the other thing is we assign a grade rating to this. It's not an elementary grade rating, but it is based on the European energy labels. So your highest is an A++, and there's an F, and energy labels do allow an E, unlike normal American grading systems. So we'll talk about that here now. So what we did then is after we kind of built it, we did some tests, make sure everything worked, we just loaded up all the schemas and ran it once to get a baseline score. And I'm going to share those results with everyone today. And we're not going to do any individual subgraphs, like I said, no blaming. So the average was, though, a D. Not very good, almost failing. From there, the schema lint was actually one of our biggest surprises to see. Although I have seen a lot of linting issues or bad naming or things like that. Fundamentally, schema linting is okay. Not great, not perfect. Maybe we need to be a bit harsher on the scoring, get that grade down a little bit, encourage people to do some improvements. The cyclical dependencies, honestly, people were really good here. They got A++ was the average. Only very few people had a low score, or subgraphs had a low score. So that was really exciting to see. People aren't abusing that. Stale fields, though, that was the worst. Big fat F. We have a lot of teams we're reaching out to and saying, okay, we see large swaths of your schema really aren't being used. It makes it hard to read, understand what's actually needed, not needed. Larger attack surface area, anything with any regular API that has unused fields or no need. Let's clean it up and let's get it going. So, oh yeah, and the last one, sorry. Nullability. That was also A+. We saw a few really deep chains. I think 10 or 12 was probably the deepest I remember spotting when running this. But for the most part, people did a really good job at making sure that they're using null and non-null very well and when to use it. We had a couple of smaller incidents with people not using it and crashing entire pages correctly. And I think those guidelines that we put into place afterward have really stuck with teams as they're building their graphs out. So what does it actually look like currently? Well, we built a dashboard for teams to track it. Here's some mostly mock data. Renamed the subgraphs and put in some trend data to make it look a little nicer. But effectively, they have overall schema maturity score at the top. They can see their schema trends in the center. This is for the aggregate graph score. And then the individual subgraphs at the bottom. So you can go to your individual subgraph and see your score. And we're also now working on trend lines for the individual subgraph as well. So teams can effectively calculate that or see those scores over time and make actions upon it. The data we also do here is you can't really see. We do the commit ID, so you can hop to the commit, the latest one, and kind of see what may have lowered that score and things like that as well. All right. So now, there are some drawbacks to this approach, and we're going to try to fix those drawbacks in kind of handling the next stuff. So one thing is, there's not really any feedback yet other than that dashboard. So one thing we do is we want to have this closer in the development lifecycle. So we want to display scoring during the dev process in MR. For linting, we already had our lint bot that we created, and the lint bot does two things now. It shows you the warnings and errors within your subgraph, and it also shows you if you're doing breaking changes now. We just reuse the same bot for that, since we have that centralized service that makes it really easy to do so. But we want to provide the grade scoring now in there as well when they're doing dev in their test environments. The next thing we really want to work on is providing reports on actually what went wrong. Right now, they just get a thing that says, you have a bunch of old fields. Not very helpful right now, right? So we actually want to send reports. OK, here are the fields that are stale. Go clean them up, and provide some way to make that easy for them. Same with cyclical dependencies or nullability blast radius. We really want to just say, these are the fields that are bad and wrong or need some adjustment. And then lastly, provide links directly there to how to improve. We have some guidelines for each of these things that we're checking on how to improve it. But having some direct links there makes it easier for people to go out and see what's going on. Now, what else? There's no trust me, bro. Linting normally has, like, you can say, no, trust me, this is OK, I promise. We don't have that right now. And that was actually very deliberate. Really, we want to create a baseline and understand what's going on, get feedback from teams, and kind of incorporate that into the scoring system itself. In the future, we'll certainly add this, especially things like nullability and cycle dependencies. Like sometimes they're just simply required for the specific use case, and we don't want to knock teams for doing it, but we want to get teams kind of in the habit of thinking about these and working on them a bit more in depth. The other thing we need to work on is we don't really have a holistic view. I showed the aggregate score of all the subgraphs. Right now, that's just a simple average of all the subgraphs. The supergraph is greater than the sum of its parts, or in some cases, can be worse than the sum of its parts. And that's because things like cyclical dependencies can exist only in the supergraph. Nullability issues can only exist in the supergraph on occasion. So the next thing that we're going to also work on is effectively, when these things get merged, we're going to run this entire process against the entire supergraph and add scores to that as well. So people kind of get a better idea of how your changes impact the entire graph. The other one is integration into service maturity. So I talked a little bit about service maturity within Booking.com earlier. One of the things I didn't mention earlier was every week, every team is supposed to have all hands with their team and discuss what's going on with their service, what's been working well, what issues are going on, what outages they may have been experiencing, or other new errors and warnings that are cropping up. So we want to integrate this into part of that service maturity review that they do every week. So they say, oh, our schema scores are going down. Let's take a look at why that's happening and what can we do to improve that. The other thing is with, not everyone agrees with these metrics. Especially adding them to service maturity. That's kind of a big debate right now. And as we add more scores, as we want to get more into service maturity and add this into service maturity for teams to review, we do feel that we need some more stuff or more scores in there, especially like the requires directive ones and things like that, and things to action directly on, because right now we're still having teams fly a bit blind when we give them a big fat F for stale fields, for example. But ultimately, integrating into service maturity makes this part of the best standards and practices within Booking, and that's really important to us. We do feel that the schema at the end of the day is really a reflection of your service and how your clients use your service. So having a good schema means you're going to have a good service, at least for the data part of it. Lastly, I think it's required by law at every conference now. I have to throw in AI. Not a whole lot of use cases yet. We have AI planned for other stuff, and I think it's the same as everyone else. Like we want to do AI for schema analysis in the sense of writing queries and that kind of stuff. But we also discussed usage intent versus execution. How does these things play into the larger graph? Things that are a bit more difficult to define by an automatic process. So like groupings of items, namings, not necessarily type collisions, because obviously checks handle that. But just kind of stuff like, oh, these types are really similarly named. Are they just the same data but being provided by different services? So that is a potential use for AI, but we'll see. Lastly, any questions? I got a question back there.
Yeah, so the unused fields
Yeah.
Store this information are taken from the production.
Yeah, so we use Apollo for the analytics and the field usage. So we just pull that information directly down, and then when we get the subgraph in, we just parse it against that data, and we just flag it as used or unused.
And you use different environments, so you take this information from different environments, so production.
So all information is checked against production. So even if you're doing a change in dev, we check it against production. Because we want to catch that early in the life cycle. That if this field is old. Let's do something with it. That we also, because also then like dev, like the number of requests per second is like 1/1,000,000th of the requests that you see in production, and same with like our staging environments as well. So we don't really see checking against our DQS and dev environments makes a lot of sense. Always production. And we do the same with when you remove fields and check for breaking changes. In dev, it will flag it. If you remove a field in dev, it will flag that, hey, production is using this. Once again, we want that early notification in the dev lifecycle. I think you went first.
Okay, sure. Yeah. Thanks so much for the class as well.
Yeah. Yeah, no, I think that's a really great idea. I will say Booking, we don't do a whole lot of open source, and that's something I would like to improve. But fundamentally, we also want to see the kind of the value at the end of the day, right? Like, we're just getting started with this. It's only been going for a few months. So we want to see if this actually makes a larger change or not. But if it does, I think this is really something good to bring back, at least a set of guidelines and standards for the community to do, because some stuff might be very booking specific, for example. The guy in the green there, sorry. Yeah, so the biggest, for the AI type duplication, that is really AI. Like if it kind of looks like a duck, but a duck and a chicken the same thing, it's close, right? Like how exactly do you kind of spot those differences and what's similar? For if you're just proxying REST, that one's trickier, but there is the big tell of if you have just a large flat object, it's usually a pretty good sign you're doing that. And we also, when we onboard new graphs, for the most part, we do pick that up. It's usually very uncommon for a subgraph to go ahead and go, oh, now I'm going to call this other REST data service and proxy it up and keep that really flat. It probably does happen, but like it's not super common. We usually catch that. But flat fields are probably the best way to do it. But maybe we need to do some other like introspection down the graph and kind of see what else we can do to detect it. That's a really good point. Yeah, so ESLint, the linting one, we just use GraphQL ESLint. There's a couple of internal patches for it due to the federated graph and the size. There was a couple bugs. One finally got fixed in the upstream. But all of them, effectively, we parse the graph by hand. We actually found it quite easy to do. Like, don't be afraid to iterate over your graph and your schema. It's actually really not that hard. The libraries are really good. And there's really not much going on. It makes it honestly a lot simpler. I found it easier to parse the schema in the graph than writing our own custom GraphQL ESLint plugins. So yeah. Question up front?
Yeah, I just have a question. So we're just going to keep it that way?
Gotcha. OK, so for the first question is the time frame. So for time frame, we really haven't set any hard guidelines, things like that. We want them to add it to their service maturity discussions every week and start fixing it. The stale fields is probably the big first one that we're going to start doing some serious pushing on to clean it up. I can't share the exact numbers, but it's not great. The average is an F, like I said, so it is quite low. We really want people to start cleaning up their stuff. But it's beyond just my team to kind of dictate that. It is, up to kind of, a company-wide initiative to kind of clean this stuff up. So there's no specific guideline for it yet. But probably over time, we will make some time frames and guidelines to start getting scores up. For the other one, like, is it OK to do this? Or I guess you were saying, like, who should own it or what? Effectively, that's where the trust me, bro stuff is going to kind of come in. We do want people to say, like, this is OK. I promise it's OK, and go on it. Like, we're not here to block or stop you from doing stuff in your schema. We're here to provide guidelines. Like I said, we have 130, 140 subgraphs now. I can't look at everything. We just really want people to try to do the best that they can to follow the best practice that we set forward. But maybe AI can be the benevolent dictator that Federation needs and just make everything better for us. But we'll see. Question in the back there, Eric?
Have you ever considered including performance into the scoring to basically extend it to a subgraph scoring instead of a schema scoring?
So performance metrics for subgraphs is actually another topic we've been discussing since we have some misbehaving subgraphs, for lack of a better term. But yes, there are some considerations in how to score and rank subgraphs, especially involving their criticality in the business flow and the process flow. Are they high critical, low critical, and things like that. But I think this will probably, that is a good point, evolve into kind of subgraph maturity versus just schema maturity. But yeah. Guy in orange?
I was just double ask the same one because you mentioned all the time people are ignoring the literals, or?
No, so I'll explain this. I probably glanced a bit quick too over it. Effectively, for every object, you get a point. For every field, you get a point. So let's say you have 100 objects in 500 fields. You'd have 600 points. So if you have an error, we deduct 2 points from that. If you have a warning, you get 1 point deducted. And then we have
Or necessarily apply from the beginning.
yeah,
Okay.
yeah. And then, yeah, it just floors out at 0, or technically 1, because FYI, with a harmonic average, you can't have a 0 because you end up dividing by 0. Any other questions? If there's nothing else, thank you. I would really love to discuss later about best practices. The next one we're going to plan to work on is probably the requires directive and overloading it with fields. That one's a bit of a hot topic, mostly because we're not quite sure the best way to score it. Sometimes you need to add a bunch of fields, but sometimes it's probably a bad idea. And it probably requires understanding the full graph to understand if it's a good idea or not. And I'd love to hear also orchestration with requires and kind of the drawbacks you found with that. But I'd also love to hear later, when we're out there, discuss what other ideas for scoring you have, because I think there's plenty more ideas to go. All right. Thanks, everyone.